You use electricity every single day. You drive on roads. You drink running water. You live in buildings that shouldn't be able to stand. And none of it, not one single piece of it, would exist without 15 machines that almost nobody alive today has ever heard of. Some of them were destroyed on purpose. One of them was built 2,100 years ago, and we still can't fully figure out how it worked. And the one at number 1 was invented twice by two completely different people who never once met each other. This video is about the machines that built your world. Not the famous ones, not the ones in every textbook. The forgotten ones. The ones that got erased, ignored, or buried, even though without them, human civilization as we know it simply doesn't exist. We're going to move fast through the first half, then slow down and go deep on the ones that will genuinely mess with your head. By the time we hit number 1, you're going to want to tell someone about it. Let's start.
Number 15.
The Jacquard Loom, 1804. Here's something wild. The first machine ever programmed to follow instructions wasn't a computer. It was a loom, a weaving machine. And it happened 80 years before anyone even thought of a computer. Joseph Marie Jacquard built a loom that read punched cards with holes in them, and used those holes as instructions. Each hole told the machine which threads to lift. Different pattern of holes, different pattern of fabric. You could change the design just by swapping the card. That's programming, actual programming, in 1804. The reason this matters so much is that Charles Babbage, the guy who tried to build the first mechanical computer, directly borrowed this idea. And then Ada Lovelace, the first person to write what we now call an algorithm, built on top of that. The entire logical foundation of modern computing traces back to a French silk weaver who wanted to make prettier fabric. The Jacquard loom didn't just make cloth, it taught machines how to think in instructions. And then we forgot to give it the credit. Number 14. The Newcomen Steam Engine, 1712. Everyone knows James Watt. Nobody knows Thomas Newcomen. That's the tragedy here. Newcomen built the first practical steam engine more than 50 years before Watt. His machine pumped water out of coal mines. Before it existed, miners were dying because the mines kept flooding. Newcomen's engine saved lives, kept the mines running, and powered early industry for decades. But it was inefficient. It wasted enormous amounts of heat. So when James Watt came along and improved it, everyone celebrated Watt. Newcomen got buried. Here's what makes this painful. Watt didn't invent the steam engine. He fixed someone else's. Newcomen had the harder job. He had to imagine something that had never existed. Watt just had to make it better. We'll come back to Watt later, because this story gets more complicated.
Number 13.
The Difference Engine, 1822. Charles Babbage spent his entire life trying to build a machine that could calculate mathematical tables automatically. He called it the Difference Engine. He got funding from the British government. He spent years designing it. And then he never finished it. Not because the idea was wrong, the idea was perfect. The engineering of his time just couldn't keep up with his vision. The tolerances required, the precision of each individual gear, were beyond what Victorian machinists could reliably produce. Babbage died in 1871 without ever seeing his machine work. In 1991, the Science Museum in London built the Difference Engine from Babbage's original plans. It worked perfectly. He was right. He was just 170 years too early. The irony is almost cruel. The man who conceptually invented the computer couldn't build it because the world wasn't ready. And the world moved on without him. Number 12. The Spinning Jenny, 1764. James Hargreaves invented a machine that let one person spin 8 threads at the same time. Before the spinning jenny, you needed 8 people to do that work. After it, you needed 1. The workers found out, and they burned it. Not metaphorically, they physically broke into Hargreaves' home and destroyed the machines. Because they understood exactly what this meant. Their jobs, their entire way of life, were being replaced. The fear was completely rational and completely understandable. But here's the thing. The spinning jenny didn't destroy jobs in the long run. It created an explosion in textile production so massive that it actually generated more work in factories, in distribution, in raw material supply. The industry grew faster than the machine could eliminate positions. That doesn't make the fear wrong. It makes it complicated. And it's a pattern we're going to keep seeing. Technology that terrifies people in the short term and transforms everything in the long term.
Number 11.
The hydraulic press. 1795. Joseph Bramah invented the hydraulic press. And here's the most remarkable thing about it. The design he came up with in 1795 is essentially the same design used in hydraulic presses today, 230 years later. Almost nothing has changed. The principle is Pascal's law. A small force applied to a small area of fluid creates a proportionally massive force on a larger area. You push a little, the machine pushes back with thousands of times more power. Bramah's press could exert forces that no human, no animal, no other machine of the era could match. It was used to shape metal, compress materials, and eventually to build the infrastructure of the industrial age. The reason it hasn't changed is simple. It was already perfect. You don't redesign perfection. But here's the thing about the hydraulic press, and we'll come back to this. Bramah's name is about to come up again, in a very different way. At number 1. Number 10.
The Rotary Printing Press.
1843. Richard Hoe invented a printing press where the type was mounted on a rotating cylinder instead of a flat plate. This sounds like a minor mechanical adjustment. It wasn't. The flatbed press that Gutenberg had pioneered could print maybe 250 pages per hour. Hoe's rotary press could print 8,000 per hour. Within a decade, newspapers that had been luxury items for the educated and wealthy became cheap enough for anyone to buy. Mass literacy accelerated, political awareness spread, public opinion became a force that governments had to reckon with. But, and this is the part people forget, the same machine that spread truth also spread lies at industrial scale. The first era of mass misinformation happened not online, not on social media, but in the 1840s and 1850s, when newspaper owners discovered that sensational stories, true or not, sold more papers. We invented fake news in 1843. We just didn't have a name for it yet.
Number 9.
The Bessemer Converter. 1856. Before Henry Bessemer, steel was expensive, brutally expensive. It took days to produce small quantities of high-quality steel, which meant steel was reserved for small, precise things, tools, weapons, surgical instruments. Bessemer figured out that if you blasted air through molten iron, the oxygen would burn off the impurities and produce steel in minutes instead of days. His converter, a giant pear-shaped vessel that tilted and roared and spat fire, could produce steel faster and cheaper than anyone had ever imagined. The price of steel dropped by 80% within a generation. And here's what that actually meant. Skyscrapers, rail networks that crossed entire continents, bridges that spanned rivers nobody had ever bridged before. the Brooklyn Bridge, the Eiffel Tower, the Transcontinental Railroad. All of it was waiting on cheap steel. Bessemer gave them cheap steel, and the modern world followed.
Without the Bessemer Converter,
The skyline of every city on Earth looks completely different, or doesn't exist at all. Number 8. The Aeolipile. Around 50 AD. This one is going to bother you. Hero of Alexandria, a Greek engineer living under Roman rule, built a device where a sphere of water was heated until it produced steam, and the steam escaped through two nozzles mounted at opposite ends of the sphere. The escaping steam caused the sphere to spin. That's a steam engine, a real, functional steam engine, built approximately 50 AD. The Industrial Revolution didn't happen until the 1700s. That's a gap of 1,700 years. Why? Because nobody in the ancient world figured out what to do with it. The Aeolipile was treated as a curiosity, a toy, a demonstration piece. Slaves did the work that machines could have done, so there was no economic pressure to develop the technology. And without that pressure, the idea just sat there, spinning, going nowhere.
the most haunting question in the history of technology is this.
What if someone had figured it out? What if the Industrial Revolution had happened in 200 AD instead of 1760? Where would we be right now? We'll never know, because the machine that could have changed everything was forgotten for 17 centuries.
Number 7.
The telegraph machine, 1837. Samuel Morse didn't invent the telegraph alone, but his name is on the code, so he gets the credit. Either way, what the telegraph did to human communication was nothing short of revolutionary. Before the telegraph, information moved at the speed of a horse. If something happened in London, people in New York found out weeks later when a ship arrived. Wars were fought over territories that had already changed hands. Business decisions were made on information that was months out of date. The telegraph changed that overnight. Suddenly, a message could cross a continent in minutes. Stock prices in one city could influence trades in another city in real time. A battle could be reported before the wounded had been evacuated. The world shrank. Think about what that actually felt like to people alive in 1845. Your entire life, news had taken weeks to arrive, and then suddenly, minutes. It must have felt like magic. It must have felt like the world had fundamentally changed. Because it had. The telegraph was the internet of its era, the first network, the first time humans were connected across distance in real time. And we treat it like a footnote. Number 6. The Mechanical Reaper, 1831. Cyrus McCormick built a machine that could harvest grain mechanically. Before it, harvesting was done entirely by hand. Armies of workers with scythes, moving through fields for weeks at a time. It was exhausting, expensive, and limited by how many people you could find and pay. McCormick's reaper did the work of 5 men, then 10. As the design improved, more. One machine and one horse could harvest more grain in a day than a team of laborers could manage in a week. The result? Food got cheaper, farms got bigger, cities could grow because fewer people were needed in the fields. The population of America's cities exploded in the second half of the 1800s, partly because the mechanical reaper freed people from agricultural labor. But here's the irony. McCormick spent 30 years in court fighting patent disputes over his invention. 30 years of lawsuits, while the machine that was feeding millions of people was being argued over by lawyers. He won, eventually, But the story of the mechanical reaper is also the story of how human beings can take something genuinely world-changing and immediately start fighting over who gets paid for it. Some things never change. Now, before we get into the top 5, I need you to do something. If you're finding this interesting, and I think you are because you're still here, hit subscribe. This channel goes deep on the history that actually explains how the world works, the stuff that got left out of school. And I think you're going to want to be here for what's coming next, because the next 5 machines are a different level entirely. We're slowing down, we're going deeper, and number 5 is going to make you question everything you think you know about human history. Also, stay for number 1. It's the only machine on this list that was invented twice by 2 completely different people who never once met. And the story of how that happened is genuinely one of the strangest things I've ever researched. Number 5. The Antikythera Mechanism, around 100 BC. In 1900, sponge divers off the coast of a small Greek island called Antikythera found a shipwreck. Among the artifacts they pulled from the seafloor was a corroded lump of bronze. Nobody paid much attention to it at first. Then researchers started X-raying it, and what they found inside changed our understanding of ancient history. The Antikythera Mechanism is a mechanical computer. Built around 100 BC, it has at least 30 interlocking bronze gears. It could predict solar and lunar eclipses. It tracked the positions of the known planets. It calculated the dates of the Olympic Games. It showed the Metonic cycle, a 19-year astronomical pattern, with extraordinary accuracy. This is not a simple device. This is a machine of breathtaking sophistication, built more than 2,000 years ago. And here's what makes it truly disturbing. We have found exactly one of them. 1. In 2,100 years of human history, across thousands of archaeological sites, we have found a single example of this technology, which means either it was extraordinarily rare or almost everything like it was lost or destroyed. Modern researchers, using the most advanced imaging technology available, have spent decades studying it, and they still haven't fully reconstructed how all of it worked. There are mechanisms inside that we can see but can't explain. A machine built by human hands 2,100 years ago contains engineering that our best experts haven't completely decoded. Let that sit for a second. What else did the ancient world build that we've never found? What other technologies were developed and then simply lost to war, to fire, to time? The Antikythera Mechanism isn't just an incredible artifact. It's a reminder that human ingenuity doesn't move in a straight line. It advances, and then it disappears, and then it has to be rediscovered. We think of history as progress. The Antikythera Mechanism suggests that's not always true. Number 4. The Watt Steam Engine. 1769. We talked about Newcomen. Now let's talk about what Watt actually did, and why the story of credit in the history of technology is so complicated. James Watt was a scientific instrument maker at the University of Glasgow. In 1763, he was given a model of a Newcomen engine to repair. He fixed it, and while he was fixing it, he realized something. The Newcomen engine wasted an enormous amount of energy because it heated and cooled the same cylinder over and over. If you could separate the condensation from the cylinder, have a separate condenser, you could keep the cylinder hot all the time and stop wasting heat. That was Watt's insight. Not the steam engine, the separate condenser. It sounds small. It wasn't. Watt's improvement made the steam engine roughly 4 times more efficient. Suddenly, it could be used not just to pump water, but to drive machinery, mills, factories, Eventually, locomotives. Watt partnered with a businessman named Matthew Boulton, and together they commercialized the engine brilliantly. They licensed it, they marketed it, they measured its output in a unit called horsepower, a marketing term Watt invented specifically to help customers understand what they were buying. He was selling power, and he knew how to sell it. But here's the irony that history doesn't usually mention. Watt also used his patents aggressively to block competitors. For 25 years, while his patents held, other inventors couldn't legally improve on his design. Some historians argue that Watt's patent protection actually slowed the development of steam technology, that the Industrial Revolution could have moved faster if Watt hadn't legally locked down the field. The man who accelerated history may have also pumped the brakes on it, and he got all the credit. Newcomen, who had the original vision, got the footnote. Watt, who had the brilliant improvement and the brilliant business sense, got his name on the unit of electrical power used in every country on Earth. That's how history works. It doesn't always reward the right people. It rewards the people who know how to make the world pay attention. Number 3. The Linotype machine, 1884. Before the Linotype, setting type for a newspaper was done by hand, letter by letter. A skilled compositor could set maybe 1,500 characters per hour. A full newspaper page might contain 10,000 characters. You do the math. Ottmar Mergenthaler, a German-American watchmaker, built a machine that could set type mechanically. You typed on a keyboard. The machine assembled metal letter molds, cast them into a solid line of type, a linotype, hence the name, and returned the molds automatically for reuse. A linotype operator could set 6,000 characters per hour, 4 times faster than a human compositor. And the machine worked continuously, without fatigue, without breaks. The result was that newspapers could be produced faster, cheaper, and at larger scale than ever before. The New York Tribune was one of the first major papers to adopt it. Within a decade, virtually every major newspaper in the world was using linotype machines. For 80 years, the linotype was the backbone of print journalism. 80 years. And in all that time, nobody found a better way to do it. Then computers arrived, and the linotype, the machine that had been indispensable for 8 decades, became obsolete almost overnight. Not because it stopped working, because something faster came along. The last professional linotype operators retired in the 1970s and 1980s. They had spent their careers mastering a machine that no longer existed in the industry. The skills they had developed over decades, the feel of the keyboard, the rhythm of the casting process, the ability to work at speed without errors, all of it made irrelevant in a few years. There's something quietly devastating about that. A craft that took years to master, erased not because the craftsman failed, but because the world moved on. The linotype machine is forgotten today, but for 80 years, it was the reason you could read the news every morning. Number 2. The Treadle Lathe, around the 1400s. This one doesn't get a dramatic invention story. There's no single inventor, no patent, no famous name attached to it. It just appeared, gradually, across medieval Europe, and it changed everything. A lathe is a machine that spins a piece of material, wood, metal, bone, so that a cutting tool can shape it symmetrically. The treadle lathe added a foot pedal that allowed the operator to power the machine with their leg, keeping both hands free to guide the cutting tool. That sounds simple, but think about what it enabled. Before the treadle lathe, making a perfectly round wooden wheel was an enormous challenge. Furniture legs that were truly cylindrical were rare and expensive. Anything that required precise rotational symmetry had to be done slowly, by hand, with great skill. The Treadle Lathe made precision accessible. It gave craftsmen, carpenters, wheelwrights, furniture makers, weapon makers, the ability to produce consistent, accurate, symmetrical objects at a pace that had never been possible before. Every wooden wheel on every cart that moved goods through medieval Europe, every turned chair leg, every wooden handle on every tool, every wooden component of every machine that came before the Industrial Revolution. All of it ran through the Treadle Lathe. It's forgotten because it was everywhere. Things that are everywhere become invisible. We don't notice the infrastructure that holds everything up until it's gone. The Treadle Lathe held up the pre-industrial world, and almost nobody knows its name. And now, number 1, the Bramah Hydraulic Press, 1795. We already talked about Joseph Bramah at number 11, but here's what I didn't tell you then. Bramah didn't invent the hydraulic press alone. He invented it with a man named William George Armstrong. Except Armstrong was born in 1810.
15 years after Bramah's press was built,
They never met. Armstrong didn't know Bramah's work when he started his own investigations into hydraulic power. Two men, two completely independent lines of inquiry. The same fundamental machine. Arrived at from completely different directions, separated by time, with no communication between them.
how does that happen?
Here's what I think, and this is the part that genuinely fascinates me. By the 1790s and again by the 1840s, the underlying knowledge, Pascal's law, the behavior of fluids under pressure, the engineering of pistons and cylinders, had reached a point where the hydraulic press was, in a sense, inevitable. The pieces were all there. Anyone who assembled them correctly would arrive at the same answer. Bramah assembled them in 1795. Armstrong assembled them independently in the 1840s and went further. He built an entire system of hydraulic power for the city of Newcastle. Hydraulic cranes, hydraulic lifts, a hydraulic power network that let factories and docks operate machinery without individual steam engines. Armstrong's hydraulic systems were eventually installed across London. The Tower Bridge, one of the most iconic structures in the world, runs on hydraulic power. Armstrong's hydraulic power. But Bramah got there first, and neither man got the full credit they deserved, because the story was split between two people across 2 generations. This is the deepest thing the history of technology teaches us. Great inventions are rarely the product of a single genius working in isolation. They are the product of accumulated knowledge reaching a tipping point. When the knowledge is ready, multiple people arrive at the same answer, sometimes simultaneously, sometimes separated by years or decades. Darwin and Wallace both arrived at natural selection independently. Newton and Leibniz both invented calculus separately at roughly the same time. The telephone was filed for patent by Alexander Graham Bell and Elisha Gray on the same day. The hydraulic press is another entry in that list. 2 men, 1 machine. No meeting, no collaboration, just the same idea, waiting to be found. Found twice.
And the reason it matters,
The reason it's number 1 on this list is that it forces you to rethink what invention actually is. We tell the story of technology as a series of heroic individuals who had brilliant ideas. But the truth is messier and more interesting. The ideas were already there, embedded in the accumulated knowledge of the age. The inventors were the people who were paying close enough attention to see them. Which means the question isn't just, who invented this? The better question is, what ideas are already embedded in the knowledge of our age, waiting for someone to pay close enough attention to see them? What's the Bramah Hydraulic Press of 2025?
So let's bring this home.
We started with a Jacquard Loom that programmed fabric 80 years before computers. We moved through a steam engine that was built in 50 AD and forgotten for 17 centuries. We talked about a mechanical computer that was found on the ocean floor and still hasn't been fully decoded. We watched James Watt take credit for improving someone else's invention and then use that credit to slow down the very industry he helped create. We saw a machine that set type for newspapers for 80 years, erased in a decade. We found the invisible machine that built the pre-industrial world and never got a name. And we ended with a machine that was invented twice by two people who never met, because the idea was simply waiting to be found. Here's what all 15 of these machines have in common. They were all, at some point, either ignored, forgotten, stolen, burned, or taken for granted. The people who built them were often not the people who got the credit. The technologies that changed everything were often not recognized as world-changing until long after the fact. That's not a cynical observation, it's actually an exciting one, because it means that the machines that will define the next 100 years are probably already here, somewhere, waiting, overlooked, underestimated, maybe in someone's workshop, maybe in a patent filing nobody's read, maybe at the bottom of the ocean. History doesn't always announce itself. Sometimes it just spins, quietly, going nowhere, until someone finally figures out what it's for. Which of these 15 machines shocked you the most? Drop it in the comments. I genuinely want to know. And if you're someone who thinks the Antikythera Mechanism deserves its own full video, tell me that too, because I think you're right. If you made it this far, you're exactly the kind of person this channel is built for.
Hit subscribe
So you don't miss what's coming next. We're going deep on the technologies that were deliberately suppressed, the inventions that were ahead of their time by centuries, and the forgotten engineers who built the world you live in. The next video is already waiting for you. Don't let it sit there like an Aeolipile. Go find out what it does.